All right. Advent of Code 2023, Day 2. Yeah, it's a little trebuchet, right? And there's our star, and there's another star we're going for. I'm going to click the star. I know it doesn't matter. Day 2, Cube Conundrum. You're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. Oh, that's convenient. You gently land in a fluffy pile of leaves. I'm getting Terraria vibes. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Okay? To get information once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, show them to you, and then put them back in the bag. That sounds like a fun game. He'll do this a few times per game. Okay. You play several games and record the information from each game. We're doing science. Each game is listed with its ID number, like the 11 in game 11, colon something, followed by a semicolon separated list of subsets of cubes that were revealed in the bag, like 3 red, 5 green, 4 blue. For example, the record of a few games might look like this. In game 1, 3 sets of cubes are revealed from the bag and then put back again. The first set is 3 blue cubes and 4 red cubes. I see it. Then 1 green, 1 red, 2 green, 6 blue, and then finally 2 green. Okay. The elf would first like to know which games would have been possible if the bag contained only 12 red, 13 green, and 14 blue. All right, so this is a parsing exercise today, huh? All right. So certain games are possible given these constraints, and certain games are not possible. What is the sum of the IDs of these games? Got it. All right, I think I understand what I need to do. Get input. 2023, day 2. Ooh, okay. So we have 100 games that we played. We have game 1 through... I assume these are all in order, so we don't actually have to store the game ID. So let's start off with building our template, as we do. Here's day 2. Day 2. Day 2. Day 2. And we stick that in here. Day 02. And we'll go back here and create the module. 2023-02. Oops. Like that. And now we have unsolved and unsolved. Perfect. So parsing is going to be the hard part, right? I think everything else is going to be relatively easy. Let lines equals AOC lib, read lines, input 2023-02.text. Come on. There we go. And the input looks like this. Okay, so we can just split off turns. Let's call them turns. Is equal to, oh, we're going to loop over the lines. We can consume them. Turns equal to line.split once of colon space unwrap. And now we have all the turns. We can get a list of the turns, which are going to be split. Let turns equals turns dot split of semicolon space collect. Come on, underscore that. And that's a vector of all of our turns. So now we've got each turn split into turns. So what we can do is loop over the turns and split apart those for t in turns. And we can split by cube. Let cube equals t dot split on comma space, right? Collect vec. Oops. Now that we split them up into the different cubes, we're going to interpret each cube and create a turn. Let's create a struct turn, which contains a quantity of red, a quantity of green, and a quantity of blue. This seems like a straightforward way of doing this. And then what we'll do is we'll take a look at the cube. We're going to split it by spaces. So we're going to say let amount and color is equal to cube dot split once on space. And then amount is just going to be a usize amount parse unwrap. There we go. So we have the amount, and now we just need to parse the color. We could just use the first character of the color. Right? We can say match color is a stir. Right? Reference to, oh, it's unknown. That's a vec of stir. Why is this not known? Let me just build it and see what happens. Okay, I'm confused. Splice. I can't do a split once? What is line? Line is a string. And cube is a... Oh, cube is a vector of... Right, I have to do it for each cube. Let's go. Okay, I'm getting lost. For C in cubes. There we go. Glad I checked. It's still unknown. Oh, because I gotta rename it. There. Now this is a stir. Yay. Okay. So we're going to say match C. I can't do C of 0. Right? Because it doesn't let you do that in Rust. It has to be a range of usize. I could do this, right? And then match on R for red. And oh, we have to create a turn. Let mut turn is equal to turn default. And we'll just derive that. DV says, unfortunately, today it was all parsing. After parsing, it was much easier. Yeah, I mean, it's feeling like a lot of parsing. Red. So we're going to say turn.red is equal to amount. And we'll do the same for green and blue. And any other thing is a bug in my code. Bug in your code. Because the input is always well formed. Okay, and then after that, we've created a turn. We're going to put it on a vector. Turn list, vec new. And then we'll say, for each one of these, we'll say turn list dot push turn. And then we're going to build up the whole game this way. So games is going to be a vector of turns. Right, and then let's say here, after we've built a list of turns, we'll just say self games push turn list. Right, and that blows up because oh, expected stir found stir. So if I do that, it should do the match. Yeah, okay. And then color. Oh, that was dumb. Thank you, Russ, for pointing that out. Okay, so now I should be able to just print these all out. Debug out self games. I never use DBG. How come? I can just do it. I don't know why I never use that. Okay. That's why I don't use it, because it's painfully annoying. Okay. Let's do it the right way with println. There we go. All right, so now the turns are going to be turn. So we have 2 green, 12 blue. Oh, we got it wrong. Okay. Oh, I see. I got 2 green here, and then on the next turn I have 12 blue. Okay, so I'm looping. I'm doing the push wrong. Like this. And oh, this turn needs to be up here. Okay. I'm going too fast. That's the problem. So, okay, we have 2 green, 12 blue, 6 red, and 6 blue. Then there's no green. I'm looking over here for it. Okay, and let's just take a look very quickly at the tail of this input. And make sure that we have, the last one should be 1 blue, 5 red, and 3 green. 1 blue, 5 red, and 3 green. Perfect. Okay, so parsing's done. And Clippy doesn't mind any of this. So, right, what are we doing? We have to look to see for each game which games would have been possible. So we have to look for each one in the vector and then add up that one. All right, so we're going to say for G in self games. Oh, we want the index. Index game in self games iter enumerate, right? Then for each game, we're going to go for each turn and make sure it's valid. So, and we're counting up the valid games. Let what valid games equal 0. And we'll just output that. So for turn in games, is game already a reference? It is, so I can just say game here. We're going to check to see if it's valid. So we can just write a little if turn not turn is valid, then we're going to say continue next game. And we'll loop back up here. If they're all valid, then we could just increment valid games. Oh no, we don't want to increment valid games. Game, we'll call this valid game total. Total plus equals the index plus, I don't need parens, index plus 1. Right, we're just adding up the game IDs, the sum of the IDs of those games. All right. And that's it. And now we just have to write is valid. Impl turn is valid. Self returns a bool. And it's valid if self red is less than or equal to 12 and self green is less than or equal to 13 and self blue is less than or equal to 14. Oh, I forgot to change this. There we go. Let's run that. Let's run that without the debug output. 2771. That's the right answer. All right, let's commit those. Yeah, I already checked Clippy, right? Yeah, let's commit the changes. Git commit. Oh, git add source. Git commit -am 2023 day 2 part 1. There we go. And now let's do day 2 part 2. Let's find out what it is. Who's ready? I'm not ready. Continue to part 2. Oh, it's a long part 2. The elf says that they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get to the water source to check it out for yourself. It's just up ahead. I guess maybe that'll be on day 3 because we're continuing our walk now. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? The fewest number of cubes that could have been in the bag to make the game possible. So it's just the max. Is it just the max of each color? Again, consider the examples from earlier. Game 1, the game could have been played as few as 4 red, 2 green, and 6 blue. Game 3 must have been played with at least 20 red, 13 green. Yeah, so it's just the max, right? The power of a set of cubes is equal to the numbers of red, green, and blue cubes multiplied together. The power of the minimum set of cubes in game 1 is 48. 4 times 2 times 6. In 2 to 5, it's 12, 15, 60, 630, and 36 respectively. Adding up these 5 powers produces a sum 2286. All right. I think I understand what's being asked of us here. We just need to power sum. Let's call this the power sum. Let power sum equals 0. So what we're going to do is loop over each game and loop over each turn in each game, save the max red, green, and blue values, multiply them together, and then add them to the power sum. So we can do for index. Oh, we don't need the game index, right? We can just say game in self games for turn in game. And we want to save the max red. Let red equals 0, green and blue. We say red is equal to red dot max of turn dot red, and do the same thing for green and blue, right? So now we've collected all the maximums, and we can say power sum plus equals red times green times blue, right? 70, 90, 924. That's the right answer. How about that? Very exciting. I don't know if there's a simpler way to do this. I think that's about it. Medibi, thank you for the follow. Welcome. All right, I think we're going to call it there, right?